Now, this is my 33rd episode on on streams, and today we are going to see one more part of streams, which is uh, grouping by. But before we go into that, we will just take a problem which is related to uh, finding the frequency of counting numbers, right? So let's start this. Um, So now we are going to deal with a very simple problem here. Uh, we are simply going to solve a problem of so the, the name of the class is frequency count, and then we are going to have a array of integers, but we'll take this as list, my list. Instead of I'm saying new array list, I am going to convert an array into list. So how do I do that? Is so now what we're going to do is we're going to have this where I put four integers, 4464. We'll do a very simple exercise of counting how many times a number is repeated in arrays. So we'll take this as input java.util.arrays. Then next is we're going to have a, we'll give a first a conventional approach of finding the repetition of an integer and using a traditional approach, like you will use a for loop and then you will loop and then for each element, and then what you will do is you will store the count of that element, and so whichever is the highest count, we will try to print that. So that's what we are going to do. So since we are going to find out the the frequency of each number, how many times it has occurred in an array. We are going to take the approach of conventional, where what we'll do is maybe, we will have uh, a for loop and ordinary for loop, not even enhanced for loop. Here, what we're going to do is that we will put this list in a for loop, loop through the list, loop through loop through the loop the list thing, for loop, loop through the list using for loop. Now, after looping through the list using for loop, what we will do is we will maybe put the element as a value, element as the key, as the key, and value frequency will be the value. Frequency will be as a value in map. And then what we'll do is we will maybe print the map in the map. Now, this is the basic thing. Uh, as we discussed, we are going to have a for loop. Now, if we need a for loop, uh, I'm not going to even take the advanced for loop. I'm going to take a very ordinary for loop. Uh, why I'm showing this approach to you? All this can be done in one single command of stream, right? But before we go into the command of streams, we will have an algorithm. So when we write an algorithm, the the problem as well as solution of the problem, the steps involved in those will build a very good imagination in our mind of what is the problem and what's the solution. And then once the imagination is built very well, we will be able to utilize the same imagination for streams. That's very important. So that is why, my approach here uh, is first conventional. So what I'm going to do now, the next step is that going to write a for loop here for, I'm going to say int I equals 0, or int I equal to uh, and then I will be less than my numbers dot size. Dot size. and then I plus plus, sorry, I plus plus, and then close this bracket. And what we are going to do is that after we uh, finish the looping, we need to have a map inside this. Now we need a map here. So what kind of map? The map will have uh, the key as an integer, and then the value also is an integer. And then my map equals, I'm going to say new hash map. And then I'm going to just represent this we'll close this, and then my map is ready. We need the collection of maps, and then we need a hash map. And then what's going to happen is inside this, we are going to store my map what I will put the number first. Get I. Now I'm going to store this, and then I'm going to store first what? I will store the first time I get the first thing I'll try to store is the count. Now, first time I'm storing this in a map, and when you store this within a map, you're going to store uh, the now what we will do is that we will check if there is a key already inside this map. That means the map, my map, is already having a key. Then you put +1. That is add to it. Otherwise, you just put the my numbers and then 1. So I'm going to check if the map contains a key, which is so it will be the first pass, and if it contains a key. If it is if it is not containing, if you go here and put the count. But if it is containing, then it will just add 1 to that. So this is the algorithm which I'm going to consider, where I'm going to check if it contains the key. My map contains a key, which is the current number. And then if it contains, then I'm going to store that number, that element, and then its frequency count. So now let's see what happens. So now we are going to print the map. Let's see if we get a result for this map. We are doing a very simple thing, just to repeat. If there is a key, then we are going to do entry for that. And then if we'll add 1 to the previous entry. If there is no entry, we'll add just 1 to that. Now let's see. So the frequency of count is numbers is 4 is 3 times, 6 is 1 times. And I'm sorry to put this one right now. I don't want to get this one into picture. We are going to put this as my map. And then now I'm going to run this Java application. So we got 4 3 times, and 6 is 1 time. So I made a slight change to make the problem have more clarity. We are going to get I is the index of the for loop. So when I do a get I of this map, it's going to get me the element, that is the key. Now, if the map contains the key, then what I'll do is in the map, I'll put the key or the element, and then I'll put whatever the value, which is a count, and add 1 to that. And if the key does not match with the members.getI, which is element or key, then I'm just going to add 1 to that. So when we execute, what we get. So we are getting the frequency count of numbers as 4 is 3 times and 6 is only 1 time. It's a very simple approach. What we did is we had a list of numbers 4, 4, 4, 6, 4. We just wanted to count the frequency of each frequency of the occurrence of a number in the array. So what we decided is we loop through the for loop, right? And we put the element as a key and the frequency as a value on map. But we have not returned the complete algorithm here. What we do is check if the key is already present in the map. And if it is there, add 1 to that. 1 to that. Else, if not present, then add the key back, the value 1. This is the total algorithm now. We have a clear problem, we have a solution with imagination. Now, to keep things simple, we made a map, and after making a map, we did the looping using for loop. We added this condition, check if the key is already present in the map. So we'll try to extract the key here, right? So let's put this as extracting the key. Which is a number. Now I'm extracting the key, and if I navigate through the map, if there is the key first time in the first pass, it's going to fail and it's going to come here. It's going to add one. When you go first time, second time again, you get four. So four is already there. So this condition is met, right? And then what happens is that uh, we will add this. So let's do one thing. Let's put a toggle point here. And then let's see what happens to be more clear on what we were thinking. Now we go here. Observe this value. So this is 0, right? And this is your map. It's not having anything. So what is there in this number? Let's go step over. Now number, what is it having? It's having value 4 because it's pointing to 0. And then is this condition met? No, this is not met because the map does not contain the number. So it went directly here and then it added to the map a number. So when you step over, let's see what is there in the map. So the key is 4, value is 1. It finished this, came back to 4. So now the map is having a key and the key's value is 4. Sorry, the key is 4 and the value is 1. So let's go once again. Step over. Now, when you step over this, what does the number contain? Number contains 4. So if the number contains 4, what does the map contain? The map is also having 4. So what is going to happen? It should get inside this, right? Well, let's check. Yes, it's going here because it's matching. Now, after we execute this, what happens is that we are going to have in the map, what is the value you're going to have in the map? 0 is having the key as 4 and the value is 2. Then then we finish the map. Map is having twice. And then we have 6. So since 6 is not there, this condition is not met. It's going to put 1, right? Then again, it's going to loop. This time we have 4 again. Then we are going to get the number, which is 4, right? That is what num is showing here. So let's go over this. And then what does num show for us? It's having value of 4. And then it's having a value of 4. It is going to execute this statement if it will be true. So it has to execute this one. So yes, it's executing this. Now what is going to do is as soon as this is executed, map will have 4 and the count will be 3, right? Yes. Now you see it is 3. So it will not execute, else it will come out. So what is the value of I now? I is 3. What is the size? What is the size? Size is 0, 1, 2, 3. 0, 1, 2, 3. So it is I lesser than size right now? I don't think so. Let's see. No. So this condition was not met. That's why it printed this. Now we have a total imagination of what exactly we were doing. So just to pictorially represent what we were doing, let's go and try to find out. So now we're going to stop debugging here. So we are still debugging this, and I want to change this as declare and initialize the map, or declare the map. And we'll stop debugging now because it's very clear for us. But now we will go back to whiteboard for some pictures of what we did. Now we are in the whiteboard here. So we have this array of 4, 4, 6, and 4. We know that map will have a key and then value. So now first time what we are going to do is that the moment we find that we start picking this up, I'm going to pick up the first element here, and then we are going to put that as the key. But before we put that as a key, we're going to check if when I pick this, is the map already having a key with 4? If it is not having 4, I'll put that as 1. Now I'm going to pick up the next element again, and then I'm going to compare with the keys. It is already there. That means I'll just add 1 to that. So this will become 2. Then I'm going to pick the next element, 6. So it is going to compare with the key, and it's having 4. So 6 is not equal to 4. So I'm going to make a 6, and then I'm going to enter here 1. Right? Then again, I pick up the last element, which is 4. And then 4, it's already there in key 4. So I just add 1. So it becomes 2 plus 1, 3. This is the way the map has been incremented. So now we have the imagination of problem and solution. Now we should start thinking of a stream. So what exactly is a stream? Let's go back and think about it. Now, next part we're going to start is we're going to use streams as a grouping by. That means this is your array which has 4, 4, 4, 6, 4. First, we will take the list as a stream and then we'll do a grouping. So grouping is basically a classifier functions where you can group by some key. So I'm going to use a group by. So what keys I can pick up here? If you see this, I can pick up uh, two keys, 4 and 6. So I'll have two groups. One is key with 4 and one is key with 6. You cannot have the third one. So in the key as 4, I'm going to put all the elements which are matching this. It is 4, 4, 4, and then the key 6 will have only one element. Then what we do is that we're going to count that, and the count here we get 3, and the count here we get this 1. So here for 4 we have 3, and for 6 we have 1. Uh, this is the approach we will have when we talk of streams. So generally, list is a source of stream, and when we get the stream is having 4, 4, 4, 6, 4. Now grouping, how do we group this? This is totally a different algorithm. It's different compared to our traditional approach where we were using key value pair, but here we are finally grouping them. Uh, we are going to make keys as the numbers itself, and we are going to group them into two groups. One group is having a key 4. It's having all the values which are there in this array, which are matching to the key, which is 444. And here another key, which is 6, which will have only one element with Z. Then we do a counting and then, we print it. So this is our approach for streams, right? So let's start our approach now. What we're going to do is that we're going to comment all this. And then we are going to take this my numbers. And then we'll take a stream. And then after we take a stream, we will use the collectors dot c collectors, and then we do a dot grouping by, and then we are going to, when we do a grouping, we are going to take the key as I, and then what we're going to do is that we are going to, we got the grouping criteria as I, and then we are going to do a counting here, collectors dot counting for each KV. And then we're going to print the number, and so we are having the collectors now here. We're going to use collectors dot grouping by. What does this say here? Collectors cannot be resolved, or is not a field. So we will correct this. How do we use collectors dot grouping by? So now what we need to do is to use collectors dot grouping by, we have to say first stream dot collect. And then when we say collect, we can use collectors here. Collectors dot grouping by, and we're going to choose the criteria for grouping is as I, and the second one is we'll put the counting here for those, and then lastly we're going to print that stream. So just to iterate, to make it easy, we are what we're doing here is we are extracting the stream, then collecting, and then using collectors dot group by, and then collectors dot counting, and then we are going to have for each key value, we are going to put the number and the key. There is an issue here. What is the issue? Okay. It is saying I need to close this, which I will do is that I will close this. And we will run this program now. I hope you got some clarity on what I did. Uh, we collected this into stream and we said collect. And remember this collect, we cannot use direct collectors dot grouping by, we have to use stream dot collect. And then we have to use the different operations. So that is why you use collect and then you say collector, and the collectors is having different operations. So one of the operations we used was group by. And see, this is the group by example. Group employees by department. Employees dot stream collect collectors grouping by. Here instead of employee department, we have the numbers itself, and then we have second argument here for collectors dot grouping by, which is collectors dot counting. So grouping by not grouping. So grouping by can have a function and a classifier. It can have function and and it also can have a supplier, which shows in the last view, and a collector. So after doing this, let's run this program. So we got this number 4, frequency is 3, number 6 is frequency 1. Now, most of people, you might feel that the approach what we are using seems to be, coming with uh, an, a thinking where we shifted the approach from a conventional thinking to functional programming. It seemed to be like, overwhelming that why should we think first in the conventional approach and then come to streams? This is the approach we are going to have same time every time. No, it's not necessary. You can directly work on streams. Some of my episodes directly talk about streams to you, how to use streams. But this approach, I took it just for a clear understanding of how there can be a difference in making the algorithms when it is streams. So one thing we have to remember here is that the technique what we use to achieve results with a conventional approach or legacy approach, that algorithm might not fit when we start using streams. In the streams we totally used a different approach. We used grouping by. But you have to remember that for the sake of simplicity, if you know the SQLs, the SQL also grouping by does some same thing, right? Group by salary and all, right? So it simply makes the rows for that. We have a similar approach here. The grouping by works. We are grouping the numbers by making them as keys. Like I could make 4 and 6 keys. So this is a different technique, totally different technique. But why we want to use a different technique when the conventional approach is having easier algorithm? Because streams can finish everything in just one line. That's the importance of streams. We will deal with some more examples of streams. I have dealt when we were using streams. I discussed on different methods of streams, and then I have taken some of the examples when the collectors by is there. Uh, mm, we finished flatten array, a flat map. We use flat map here. We just use map, only map, and we also used here. Uh, we used map, we used flat map, we used group by, we used distinct, and we also will discuss some more methods which we will discuss where and exactly how to apply that. So sorry for a long explanation, but this is going to really help us if we go more deep into streams. If you like my video, please hit the subscribe button and the like button. Thank you all.